Okay, I want to review interval notation right now. So, something called interval notation. If you don't recall seeing it in a previous math class, it's not anything difficult. Interval notation. Interval notation. Now, I'm going to draw a number line. I'm just drawing a number line, and I'm going to label numbers on this number line. Remember, on the left-hand side of the number line, that's where you have the negative numbers. So let's see, how about this one? A -7. As you move this way, they get bigger and bigger. -7. Well, something like -2, +1, +3, +6. There. So I'm labeling some numbers on the number line, and I'm going to shade regions on the number line. Like right here, I'm shading the numbers between -7 and -2. Can y'all tell that color? It's black. And then to indicate whether I'm including the number or not, the endpoint, I'll put open or closed circles. An open circle means not including. A closed circle means including. So open means include. Close, no, I wrote it wrong. And open means not including. There. Do not include. So, closed circle means include the number, and open circle means do not include the number. So if you wanted to say in words which numbers are shaded black on this number line, you would say every number between -7 and -2, including -2, but not including -7. What about this? Oh, no, I don't want to use blue. I'm going to use green now, and I'm going to shade all the numbers between 1 and 3 green. If you're thinking, well, wait a minute, the only number between 1 and 3 is 2. No. This time when I'm talking about numbers, I mean all those decimal numbers and fractions out there. Like 1.325 is between 1 and 3. And let's suppose, let's say, don't include either of those. So in the green interval, those are numbers between 1 and 3, not including 1, and not including 3. Don't think, well, it's just the number 2. No, it isn't. A lot of decimal numbers in there. And then finally, I'm going to shade these numbers over here red. Everything to the right of 6, every number bigger than 6, I'm shading red, including the number 6. So if someone asks which regions are shaded, in words you'd say, okay, every number between -7 and -2, not including -7, but including -2. Also, every number between 1 and 3, not including 1 and not including 3 are included. Every number bigger than 6, or to the right of 6, including the number 6. Well, there's got to be some shorthand notation for writing that without actually having to say the words. Every number between -7 and -2, not including -7, but including 2. The way you say this using interval notation, this is a symbolic way of writing all of this. You'll use square brackets for closed circles to mean include, and parentheses for open circles. Let me show you what I mean. Instead of having to write out it to say in words, all numbers between -7 and -2, not including -7 but including -2, here's the way we write it symbolically. Parentheses, -7, comma, -2, square bracket. That's just shorthand notation for all numbers between -7 and -2, not including -7, but including -2. Algebra, so much of it is just shorthand notation. This especially. The green interval, how would I write that? Well, I'd go parentheses, because it's an open circle, 1, comma, 3, parentheses. When you're doing this interval notation, make sure you're always working left to right. Don't write 3, comma, 1. You should write these numbers, smallest number first, then the largest. Now, you always want a left endpoint and a right endpoint, but over here there's not really a right endpoint. So what I'm going to do for these arrows, you'll see me label those. These are not 8s. This is an infinity or a negative infinity. I didn't need the negative infinity, but over here, the red interval, how am I going to write it? Well, I'll put a square bracket, 6, comma, infinity. Now, let's think. For an infinity, what should we put? Open or closed circle? Well, it involves the use of this word include. This infinity is just the same thing as that arrow. It wouldn't make sense to talk about numbers between 6 and infinity, including 6 and including that arrow. In general, you'll always put parentheses by infinity symbols. And then, in order to indicate that these are all on the same number line, we're going to be putting a big O, it's a U-shaped figure, which is read union. And that just means they're all on the same number line. So here are the 3 shaded regions on the number line. Any questions on this interval notation? Open circles, you put parentheses, closed circles, brackets. When you write the interval notation, you go from left to right on the number line. We're going to not be, well, this is the first assignment in a while where we're not going to be solving equations. We're going to solve an inequality. Well, inequalities contain not an equal sign, but instead a less than or a greater than, or it might have less than equal to, greater than or equal to. But in the original statement of the problem, if you see a less than or a greater than, then you're going to wind up somewhere along the way. You're going to be drawing number lines, and you're going to plot numbers on the number line with either open or closed circles. Let's call these numbers here on the number line, I'm going to call those cut points. Because that's what we're cutting the number line in half, or in pieces. These numbers that I have labeled on the number line, out of lack of anything better to call them, let's call them cut points. Whenever we have an inequality to solve, we're going to be drawing a number line, putting numbers on there, and shading the number line. There's going to be a method to it called the cut point method. we will use the cut point method to solve inequalities. So at this point, this semester, we haven't seen anything with less than or greater thans yet. Okay? But we're about to. I'm going to pass out a little sequence of steps for something called the cut point method. My brother has told me print it out and give it to y'all. I was just going to post it under document sharing, but he said, no, when I actually give you something, you realize, oh, it's more important then if I give you a sheet of paper. So it's not a full sheet of paper, but it's going to be this little recipe that we're going to follow over and over, and it'll get the answer to anything that has a less than or a greater than in it. On this assignment 7, so I've officially, let's say this is where lesson 7 starts. Cut points. So let's say right here, this is where we've started lesson 7. We sure won't finish it, and I'll be doing a lot of, this is all I'll be doing on Monday. Okay? So, we're going to have things that have less thans and greater thans in them. Like, let's just scan through. I'm not actually going to, this isn't the first problem I'm going to do. See, notice, there's a greater than here. There's a less than or equal to here. There's a less than or equal to. We're going to have a sequence of steps, which I'm about to pass out to y'all, a paper copy of. And it looks like this. And this is what we do whenever there's something that has a less than or a greater than in it. Anytime this semester, when you see something that says solve, and there's a less than or greater than, you're going to go through this sequence of steps.